Okay, we're working in section 4.5. We already solved a few exponential equations. Now let's solve some log equations. I have the first two examples up on the screen. In example 5, we want to solve 5 times the natural log of x equals 10. How should we begin? Well, the first step is going to be to isolate the logarithm. Since the 5 is out in front, we can divide both sides by 5. That's 5 times the natural log of x divided by 5. So the 5's cancel, and we're left with the natural log of x is equal to 2. And then when we want to undo a logarithm, we want to apply an exponential with the same base as the logarithm. So what's the base here? Base e. So let's put a base e underneath both sides of the equation. And the base e exponential and the log base e cancel, and we're left with x is equal to e squared, which gives us an exact answer. Or you can type that into the calculator. E squared is equal to 7.389. 7.389 for our approximation. Okay, in example 6, we have something similar, but a little bit different. This time the 4 is inside the logarithm, and so what we want to do, well, we want to make sure we understand we're taking the natural log of 4 times x. So we can use parentheses to emphasize that fact. And we want to apply a base e exponential to both sides. So base e underneath the left side, we'll have the e and the ln cancel. And on the right side, we'll just have e to the 1.5. So when we simplify the left side, we have 4x equals e to the 1.5. And then we can just divide off the 4, and we're done. We get x is equal to e to the 1.5 over 4 for our exact answer. Or we can type it into the calculator. I've already done that. We'll get 1.120. 1.120. Okay, so that's a pretty good start. Let's go ahead and try one or two more here. So for example 7, we'll have the log of x plus the log of x plus 15 is equal to 2. And the big difference in example 7 compared to the previous examples is that now there are 2 logarithms there. And if we want to apply an exponential to cancel the log, that sounds like a good idea. What would the base be? Since the logs are base 10, then we'd apply a base 10 to the exponential. But before we do that, we need to combine the 2 logs into a single log. We need a single log. And so how do we do that? We use properties of exponents. So the sum of 2 logs can be written as the log of the product of the 2 arguments. On the other side, we just have 2. Remember, this is log base 10. And so in the next step, we'll put base 10 underneath to create the exponential. And we'll put a base 10 on the other side to get 10 squared. 10 and log base 10 cancel, and we have x times x plus 15 equals 100. And this is kind of nice because this reminds us of chapter 1. This takes us all the way back to the beginning of the course when we learned to solve quadratic equations. That's exactly what this is. We distribute the x and we get x squared plus 15x. Let's go ahead and subtract the 100 over to the other side so that the quadratic is set equal to 0. And then we can solve by factoring. X plus 20 times x minus 5 will do it. And we'll have x plus 20 equals 0 or x minus 5 equals 0. So the two solutions will be negative 20 and positive 5. And we can box them up for the moment, but we need to be careful here. We need to make sure that the values of x are valid in the original equation. And so in particular, if we take negative 20 and plug it back in to the original equation, we get the log of negative 20, which is not possible. Remember, we can only take the log of a positive number. So let's take the x equals negative 20 and cross it out and write not possible. We need to take the 5 and we need to make sure it's going to be okay. We need to make sure that the arguments for the logarithms are both going to be positive, and they will be. The log of 5 is okay, and 5 plus 15 is a positive 20, so that's okay. So we just have one answer. We have x equals 5. Okay, well, let's do one more example here, and then we'll be done with the section. So this is going to be example 8. And we'll have log of x minus 10 minus the log of x minus 6 is equal to the log of 2. Okay, so this looks pretty similar to the previous problem. There's a subtraction sign between the two logarithms on the left. So when we put them together as a single log, we'll have division. We'll have the log of x minus 10 over x minus 6 is equal to the log of 2. And then, since the base is 10 here, the base is 10 on the other side as well. We can put a base 10 underneath both sides of the equation. And then the base 10 exponential and the log base 10 cancel, and they cancel on the other side as well. And we're just left with x minus 10 over x minus 6 is equal to 2. And again, this looks like an equation from chapter 1. This is a rational equation. Variable is in the denominator. We're going to multiply both sides by the common denominator, x minus 6. And x minus 6 cancels on the left, and we're left with x minus 10 is equal to 2x minus 12. So we can subtract x on both. We can subtract 2x on both sides, and that'll get us minus x. And we can add 10 on both sides, and that'll get us minus 2. And then when we divide both sides by negative 1, we get x equals 2. Now we just need to be careful. Remember, we have to make sure that the arguments for all of the logarithms are going to be positive numbers. X is a positive, the value of x is positive, it's 2, but when we plug it in, we get 2 minus 10, which is negative. And so this is not going to work. This is not possible. And so what's the answer? What is the solution? Well, in this case, the only solution we could find didn't work, and so there is no solution to this equation.